From the banks of the Colorado River in Lake Mead to the homes and businesses in Southern Nevada, welcome to Water Smarts, the podcast pumping from the heart of Las Vegas, where we engage with the experts who keep the water flowing throughout Southern Nevada. I'm Bronson Mack.
And I'm Crystal Zelke. From how we treat it, deliver it, use it, protect it, and conserve it, the Water Smarts podcast is all about water in Southern Nevada. We hope to make you a little smarter about the one thing that keeps us all connected: water.
Hey, Crystal, how are you today?
I'm good, Bronson. How are you?
I am hanging in there, just continuing to muddle through pandemic conditions, as we all are.
I feel like we might be on the home stretch. Can you believe we've been doing this for about a solid year now?
I know we are coming up on that 1 year mark. We are recording this podcast here at the end of February, and we are just about to hit that 1 year mark. It has been a nutty year for everybody. And it's also been kind of nutty, I guess, sort of in the water world. When this pandemic first started, there were some concerns about how it was transmitted.
Yeah, I think, in the beginning, it was kind of scary. There was so much information coming out. And this is obviously completely new for most Americans that I don't know that anybody's still alive that had to deal with the pandemic. What was that, 100 years ago? And there was just a lot of information. But one thing that has always been consistent for us is that we've known from the very early start of this that COVID does not show up in our drinking water supply.
And that is a very important thing. In fact, we are going to talk a little bit about COVID. We're going to talk a little bit about water, mostly on the wastewater side, because today, here on the Water Smarts podcast, we are going to be joined by Dan Garrity, Principal Research Laboratory Scientist, and Katerina Papp, postdoctoral researcher for the Southern Nevada Water Authority. They have been working on identifying and researching COVID in wastewater. We're going to hear from them today. Dan and Katerina, welcome to the Water Smarts podcast. We are so happy to have you here with us today.
Thanks for having us.
Yep. Thank you so much.
Yeah, you bet. This is a really interesting topic. It's something that is touching every single Southern Nevadan as we all are dealing with this pandemic. Dan, I'd like to start with you. When this pandemic first hit and we started to become aware of the coronavirus in 2020, you and Katerina and the water quality research team for the Southern Nevada Water Authority immediately started checking water supplies, checking samples to ensure that the virus, the coronavirus, was not present in our water supply, and more particularly, was not present in our treated drinking water supply. So can you just kind of give us a little bit of background there when that pandemic first hit? What was your research like at that point?
Sure. So the water system here in Southern Nevada is one of the most advanced out there. So we were never particularly worried that it was going to make it into our finished drinking water, but we always want to be certain that it's not going to challenge our system or make it through. And so a lot of the research that we do in research and development here at SNWA is to address these emerging challenges. So something that we didn't know about before the pandemic hit was the SARS-CoV-2 virus. And then once we realized that virus could wind up in the feces of infected individuals, that immediately jumped on our radar as something that we wanted to look for in different water types throughout Southern Nevada. So our wastewater, our source water, and our drinking water, to make sure that it wasn't going to be an issue for public health.
Dan, SNWA looks for viruses and other contaminants in our water supply. That's just part of the general research that we're doing on a daily basis. We pull nearly 57,000 water samples each year. We run more than 300,000 tests on those samples. So looking for viruses is something we're equipped to do. Did you have to change your testing processes for this particular virus?
Right. So we can basically look for anything here at the Water Authority. So with the expertise we have on the personnel side and the equipment that we have, any chemical, any microorganism that's in water, we can look for and we can find it. And so we were set up to do the same type of research. It's just that we changed the targets based on what's the question of the day, essentially. And so when the pandemic hit, we were able to look in the literature, figure out what we needed to do to change our methods to look for SARS-CoV-2, the virus that causes COVID-19. Then once we figured that out, we could use basically the same methods that we use for other viruses to look for this pandemic virus.
And when you're looking for that virus, Dan, and you identified that it wasn't present in water at Lake Mead, it wasn't present in the finished drinking water, but you did find some signals of that virus in raw sewage. Is that correct?
That's right. So the signal that we see is its genetic material. So a virus is basically genetic material. So people commonly know about DNA. This is actually an RNA virus. So that genetic material is encapsulated by a protein. And then for SARS-CoV-2, that protein is surrounded by this lipid layer. And so that's basically all a virus is. And so what we look for is just that middle part, that genetic material, as an indication that that virus was once there in feces and then ultimately wastewater. And so when we look for that, it doesn't really tell us that the virus is infectious. And more importantly, the research that's come out shows that, in fact, the virus that we find in wastewater is not infectious. And so when we find that signal, we're finding the remnants, like the carcass of that virus in the wastewater. And from the testing that we did, we only find it really early in wastewater treatment. And so one of the great things in terms of public health is that this fragment, this virus signature, gets wiped out really early in wastewater treatment. So it doesn't even make it through the wastewater treatment train. And in Southern Nevada, that treated wastewater generally goes into Las Vegas wash. And so by removing it early in wastewater treatment, that's just another layer of confidence that it's not going to affect our water supply.
So basically, you're taking raw sewage samples and you're looking for the genetic markers that are associated with the coronavirus, but not the virus itself. You're not seeing necessarily live virus in those samples. And then you're testing the wastewater after it has gone through the wastewater treatment process, and you're finding that those genetic markers of the virus are gone. That tells us then that our wastewater treatment process is effective at doing what it intended to do, which is treating that wastewater. So, Katerina, why are you looking for the virus in raw sewage? I mean, is our testing process normally just looking at drinking water in Lake Mead, right? Not necessarily looking at raw sewage on a normal water quality type of process.
Yes, that is correct, because we want to make sure that the finished water is clean, and so that is the main target of all the analyses. However, regarding the SARS-CoV-2, we know that it's primarily a respiratory virus, right, that's causing COVID-19. And researchers have found that its genetic material ends up in human feces, and because it's present in the feces, it's going to end up in wastewater. And that was one of the major reasoning behind analyzing raw sewage, because we knew that the virus should be there. And this was sort of a measure or an estimation of the virus prevalence in a community. We can ask, if it's still present, and if so, then how much. This can allow us to make decisions about different mitigation measures and policies. And it's also one way to corroborate the clinical testing data that's happening in the community.
So more broadly, we have two groups here at the Southern Nevada Water Authority that do a lot of the testing. So we have our compliance group that deals with a lot of the drinking water regulations and making sure we're complying with those regulations. And then we also have our research and development group. And so when we talk about wastewater, that isn't something that's commonly associated with the drinking water utility, or at least testing that wastewater. But because we have an R&D group here at the Water Authority, it allows us to go beyond what a typical drinking water utility will do. And it allows us to go and collaborate with our wastewater utilities to understand the potential connection between treated wastewater discharge to Las Vegas wash and what's going to wind up in Lake Mead, which is our drinking water source. And so over the years, we've had hundreds of thousands of dollars or even millions at this point in externally funded research on this very topic. And so that's why we do a lot of wastewater research here at the Water Authority.
It's fascinating to me. It's like you guys are detectives. I mean, really, you're looking for viruses, drugs, chemicals, various things that are really coming from human waste. Is this wastewater epidemiology a new field of study?
So it's been around for actually quite a few years. I think back in 1989, Israel set up wastewater-based epidemiology to track polio in its wastewater. But the way it's being used now, it's a relatively emerging field of study, especially in the context of COVID-19. There are some companies like the BioBot, perhaps you have heard about, that were originally using wastewater surveillance to track the use of opioids in our community. And then when the pandemic hit, the researchers in the Netherlands were some of the first ones to actually use wastewater surveillance to identify specifically COVID-19 in their community. And they were, in fact, able to detect the virus or its genetic material in the raw wastewater before the health officials had confirmed any actual cases through clinical tests. It's this ability to find the virus early, even before people test positive through the clinical test, that actually sparked an enormous interest in the wastewater epidemiology field.
So that's pretty impressive. You have the ability through this wastewater epidemiology effort to really get an early identifier for the concentrations, or I guess really the scope of the virus throughout the community. And Dan, when you were studying and kind of beginning to collect these samples of raw sewage, my understanding is that we were collecting a lot of those samples from Southern Nevada's largest wastewater treatment plant that primarily serves the majority of Clark County within the Las Vegas Valley. But that really is collecting wastewater from like the east end of the valley to the west end, and from the north end out to the south end. So it's a very large area that wastewater treatment facility serves, which I assume would make it pretty hard as you're collecting your samples and doing your analysis to be able to tie back any prevalence of the virus to a specific area of town. You know, I'm thinking back to what they did at the University of Arizona in monitoring some of their dormitories and being able to get an early identifier, as Katerina just referenced there, of the fact that there was a presence of the virus in their dorms. And then the university took action to mitigate that and prevent the spread. So can you just explain a little bit about kind of what are the challenges that we see in collecting samples across such a large area, and how could that be localized to provide even more efficient data to health professionals?
Sure. So when this first happened back in February of last year, we needed to move fast. And so we had a really good collaboration with that really large wastewater treatment plant. Like you mentioned, that treatment plant receives wastewater from about 40% of the community here in Southern Nevada. And so what we found over the last year now, essentially we've been doing this, is that large facility is a great sentinel site. So it really tells us as a whole, how is Southern Nevada doing in terms of infection rate? And so when you turn on the news and you see how many cases were reported in Southern Nevada, by looking at the wastewater at that facility, it really tracks the number of new cases we're seeing on a daily basis. But like you mentioned, it's hard to make that actionable. And so that University of Arizona case study is a great example of how, as you get more specific, as you really narrow down on a particular community, or in that case, a particular dormitory, you can get wastewater data and you can have a really rapid public health response. So in that particular case, they took sewage samples every day from a bunch of different dorms on campus at the University of Arizona. At that first site where they had a hit, they talked about what they were going to do with that information, and they figured out pretty quickly, we need to go in and we need to do some clinical testing. And so at that point, they organized a rapid response, sent in some rapid testing, identified 2 asymptomatic individuals. So without that wastewater signal, that early warnings response, they wouldn't have known that those people were infected. And so by identifying those asymptomatic individuals, quarantining them, they were possibly able to prevent a larger outbreak in that particular dorm. And so that shows you the power of narrowing in on a more localized location to try to make that wastewater surveillance data more actionable.
Wow. And if you are able to do that at the local level on the dorm and prevent that spread from happening within a dormitory environment, you are preventing that spread from happening then across the campus environment, and therefore preventing that spread across the entire community where that campus is located. I mean, that's pretty interesting to see how localized you can get and the kind of response that can then be implemented in order to help prevent the spread.
Exactly. And we can look at that same example on a sewer shed basis. So we can come back to Southern Nevada. Instead of just looking at that really large facility, we've branched out and looked at all of the major treatment facilities in town. And then we've also tried to break down those sewer sheds into smaller areas. So by looking at a smaller population, we can understand if population A or B has a higher infection rate, communicate that to the local health department so that they can possibly mobilize and do something about that to try to prevent the outbreak on a larger scale.
Become a plant master and save when you apply for the Southern Nevada Water Authority's Water Smart Landscapes Rebate Program. You'll not only save money on your monthly water bill, but the SNWA will give you a cash rebate of $3 per square foot of grass replaced with Water Smart Landscaping. The program has saved our community billions of gallons of water by upgrading nearly 200 million square feet of lawn. Now that's plantastic. Get rid of the grass and make the switch today. For more details, visit snwa.com. SNWA is a not-for-profit water agency. As we're recording this podcast here in Nevada and really across the country, the vaccine is finally getting out to communities and to the people, and we're finally seeing some of the cases drop. We're not completely out of the woods yet, but other countries like Australia have been successful so far at beating the virus, and they're using wastewater to help monitor the virus in a post-pandemic world. Katerina, can you explain to our listeners what they're doing specifically there?
Australia is actually a great example of how we can use wastewater-based epidemiology in a post-pandemic phase. So back in November and December of last year, they have gone several weeks without confirmed cases of the coronavirus. And they were actually very good at using pretty strict public health measures, and they had wide compliance among the people to reduce the spread of the virus. And so this really helped them to avoid the third wave that we have all experienced here in the winter. As the virus then dissipated, Australia used the wastewater surveillance to rapidly identify and respond to any re-emergence of the virus. And so at first they got pretty consistent non-detects in their sewage water. But then in early December, the virus showed up in raw sewage in, for instance, the Batemans Bay area and also in the Apollo Bay. And then the officials, they were able to launch a pretty strong advertising campaign in that area and strongly recommended that symptomatic and asymptomatic individuals get tested, and reminded them to stay safe and healthy and to pretty much let their guards down. And so again, by using WBE, they were able to find the virus before it really spread among the population.
So this Australia example is basically our future, hopefully our future. We haven't seen non-detects since last year. So we've consistently found SARS-CoV-2 in basically every wastewater sample we've collected since June of last year. And so this Australia example shows what we should see in the coming weeks. So as we get to a point where we start seeing non-detects, we could implement something like Australia is doing, where we get non-detects, all of a sudden we see a spike, and we can send out a message to the broader community and say, hey, we found this signal in this particular area. Make sure that you're wearing your mask, you're being vigilant with hand washing and so forth, because there are infections out there. And so that's something that I hope to see in the coming weeks as our infection rate drops, and then hopefully our wastewater will follow suit and start dropping as well.
So yes, we are not quite there yet, but in the past 4 to 5 weeks, we have seen a considerable drop in the number of cases and a slow decline in the concentration of the virus in wastewater. So not only that the actual number is decreasing, but looking at specifically the data, the quality of the data that we are getting is also worse. So both of these are a good indication that we are on a slow but steady decline.
And it's actually amazing to me. So we've been doing this for a while. I have confidence in the data, but every time Katerina, every week she sends me the data and I look at it, and it amazes me that it works, because we see the drop in cases, and then Katerina will send me the data and we see the drop in the wastewater. And it's just remarkable at how those two very different data sets align. And so it really shows you the power of wastewater surveillance in getting that window into the community.
Hey, Dan, are you seeing the wastewater numbers dropping before you're hearing about the case numbers in the community dropping?
It's hard to say. I would say early on, when testing was much slower, I think you were more likely to see that. That's where you had a lot of reports, like in the Netherlands, in Connecticut, they were showing this up to 2 weeks in advance. I'm not sure we can say that with our data. I think it's pretty aligned in terms of timing. So when you see the cases, the wastewater is kind of dropping at around the same time. And I think that's something that'll be refined as we understand how people are shedding the virus in feces and the testing lags that there are. So once we have a better picture of what's happening, we'll be able to figure out which was happening first. But I don't think it's really as strong as a warning signal now, because testing has improved on the clinical side so much as the pandemic progressed.
So that's amazing. I mean, through this wastewater epidemiology research that has taken place, we're able to get an early warning signal seeing the concentrations of this virus. Hopefully we get ourselves to a point where we see those concentrations extremely low for an extended period of time, and we're able to continue this work to again provide that early warning signal should we see that virus concentration increase. Dan, can you tell us some other ways in which wastewater surveillance and wastewater epidemiology can help to stop the spread of other viruses or provide other useful data to communities?
The prime example right now is all the discussion about variants. So you have the UK variant that was kind of first on the scene, then the South Africa variant, then the Brazil variant. So there's all these variants that are starting to emerge. And that's one of the problems. As the virus spreads, you have people who are producing billions of copies of this virus. And every time you're creating a new virus, you have the potential for that virus to make a mistake as it's packaging itself. And that mistake winds up being one of these mutations. And so you have the potential for these more infectious variants to start popping up. And so the way that wastewater surveillance can be used is that wastewater is a pooled sample from up to thousands or tens of thousands of people. So instead of going out and looking at individual clinical samples and sequencing thousands of clinical samples, we can go out and we can sequence one wastewater sample to see what strain of that virus or what strains more accurately are circulating in a community at any given time. And so that's something that will really pick up in the coming weeks as people transition just from going from what's the concentration to what are the strains that are in this wastewater so that we can know whether that UK variant is already here or that South Africa variant is already here. Another example that I can give you is school reopenings. And so we saw that with the University of Arizona example where they were looking at dorms, but now we have elementary schools that are starting to open here in Southern Nevada. And so another way that this can be used is to monitor sewage that comes from elementary schools and to know whether there are active infections in that elementary school as certain schools reopen. So I think that's something that's going to start popping up, not just in Southern Nevada, but elsewhere across the country to understand the role that schools might play in spreading COVID-19.
Wow. So it really is more efficient to be able to do kind of this pool sampling and this pool testing through the wastewater because you're getting a much broader view of the community and whether or not there might be variants there. Otherwise, you'd have to do that on an individual testing basis, which would be relatively inefficient. Hey, Katerina, what are some of the things that this research has been able to confirm in Southern Nevada?
So the sequencing is very important, and currently it is being done by Dr. O at UNLV. On our side here, we are using a different method that doesn't allow us to specifically identify the whole sequence of the whole genome of the virus, but rather just short targets. And by doing so, we can quantify those short targets. Now, a drawback of our approach and of using the WBE in general and of the pooled sample is that we cannot really piece those targets together. So we get a bunch of different reads that some of them will be associated with the UK variant, some of them could be associated with the South African variant or the US variant, but it turns out that, for instance, the UK variant needs to have 2 mutations that we can detect separately, but not necessarily together. So getting the 2 mutations doesn't mean that they come from the same genome and therefore indicating that the UK variant is indeed here. Nevertheless, it's a lot cheaper to sequence and analyze a pooled sample like we are getting from wastewater as opposed to clinical samples.
I'm assuming that the higher the concentration of the virus's genetic markers in the sewage samples, the higher the infection rate in the community. Dan, what is SNWA doing with the data it's collecting?
So when we get the data each week, I first send out a kind of an informal update to our wastewater partners so that they know what we're finding in the samples that they're providing. And then we also have contacts at the Southern Nevada Health District. And so for the past few months now, we've been sending updates to SNHD and breaking it up by sewer shed so they can see what we're seeing on the wastewater side and whether that aligns with what they're seeing on the case side. There have been examples where we have certain sewer sheds where the wastewater concentration is higher than we think it should be based off of where the case data is. So I think going forward, one of the powerful aspects of this is that we can hopefully increase confidence in this type of data set so that Southern Nevada Health District can, and other public health agencies around the country, around the world, can use this in an actionable way. And so when we see those discrepancies, when we see the higher wastewater concentrations, then they could potentially send out a mobile testing unit to those locations in a future pandemic. Because unfortunately, we're probably going to be in this type of situation, hopefully years in advance, but it's probably going to happen again. And so we need to refine this tool so that we can implement it much more quickly this time than what we did here. But also going forward, like we had mentioned earlier, there's potential to implement this for not only SARS-CoV-2, but basically any type of disease that you can have within a community, particularly ones that are shed in feces. But even something like influenza, people will shed that in their feces. And so even on a normal year, we can look for influenza in wastewater and provide that type of information to the health district so that they know that there's a spike in flu in one area versus another and potentially respond in that way.
That's so interesting. In one of your research papers, you note that anthropologists study artifacts left behind by people of the past. But by studying raw sewage, scientists, utilities, public health professionals, and policymakers are turning to sewage as a window to society. What do you mean by that?
It means that poops don't lie. So whatever we do as people, it's going to wind up in our wastewater. And so that wastewater is that window into society. So it's what diseases are being circulated within a community. What type of behaviors are people having in a community? And so we talked about illicit drugs in the past. We had done a Super Bowl study about 10 years ago now, where we looked at the population of Southern Nevada and how it changes during a special event like that. So during the Super Bowl, our population can increase as much as 15% here in Southern Nevada as people visit the city, go to casinos and gamble on the game and have a good time. But those behaviors are reflected in the wastewater. And so we can see during a special event like that, we can see illicit drug use goes up. And then on a normal weekend, that illicit drug use goes down. And so that's just another example of that window into society. Specifically for COVID-19, I can share this story about my friends. So we have this chat group. And so since this started, we've been talking over chat since we haven't been able to see each other in person. And so they've been following what I've been doing with wastewater surveillance, and they've seen some of the news stories. Pretty early on, when I was telling them that you can find this virus in feces, they were more than willing to provide samples of their own. First, they wanted to drop it off at my doorstep, and I told them that this was not how it worked. And then they decided, okay, well, we can send him samples by flushing it down the toilet. And so every time that they would flush the toilet, they would send me a text message saying that they were submitting samples for our research. And so then I'd be able to go collect those samples at the treatment plant. Katerina would analyze that, and then I could send the data back to them and tell them what it looked like.
You got some pretty funny friends, Dan.
They at least think they are.
I hope they weren't sending pictures.
No pictures, thankfully.
Well, I got to tell you, it's good to hear that your friends are helping with wastewater surveillance. I suppose that every Southern Nevadan who was using the facilities at one time or another has the potential to contribute to this important research effort that is taking place on a community-wide basis. I think on that note, we will thank Dan. Thank you so much for your time. Katerina, thank you for all that you had to share on the efforts and the work that you are doing from a wastewater surveillance standpoint, helping to keep this community safe, sharing that information with our partners. And I guess we just really need to give a nod to our other partners that are associated with this research, the wastewater treatment agencies that really partner with us and help us acquire these samples. That's the City of Las Vegas and the City of North Las Vegas. We can't forget about the City of Henderson and the Clark County Water Reclamation District, as well as the City of Boulder City. And then correct me if I'm wrong, but we've also got partners with UNLV and the Southern Nevada Health District. We are appreciative of all of their support and all of their efforts on this important work that Dan and Katerina are doing. Thanks so much again for joining us on the Water Smarts podcast.
And thank you for giving us the opportunity to share our research with the community.
Thank you.
The Water Smarts podcast is brought to you by the Southern Nevada Water Authority, which reminds you to follow the mandatory seasonal watering restrictions. You can find your assigned watering days on SNWA.com. You also can find landscape tips and rebate coupons to help you save water and save money.
And one of those rebates is for the Smart Irrigation Controller. Smart Irrigation Controllers can help you adjust your watering schedule depending on the weather.
Smart controllers shut off your landscape irrigation automatically when it rains. We could save 91 million gallons of water a day if everyone in the valley shut off their irrigation on rainy days. That's enough water to serve your home for 558 years.
And most smart irrigation clocks let you manage that irrigation schedule through your mobile device. You can sit on your couch while changing your irrigation clock to follow the seasonal mandatory watering restrictions. And the SNWA will give you a rebate of up to $100 off the purchase price of a smart irrigation controller. Go to SNWA.com and get your coupon now. Wow, Crystal. So really hearing from Dan and Katerina, it's pretty impressive to see the level of work that is going into not just protecting the water supply and making sure that we have a good understanding of the quality of our drinking water, but even on that wastewater side, like being able to get this data to provide it to health experts here in Southern Nevada. I mean, that's really helping to have a community response to this pandemic.
It is. And I even feel it kind of puts me at ease knowing that it's not just the COVID part, that they've been able to study and research, but it's everything else that ends up in our water. So I find that fascinating. And as a citizen of this community, I feel comfortable knowing that there are people who have the smarts and the scientific background to let us know that our drinking water is good and safe here.
That is right. There is no virus in that drinking water. Our drinking water meets or surpasses drinking water standards established under the Safe Drinking Water Act. Well, that's it for this episode of Water Smarts. We hope that you subscribe and listen next time. And if you have a question that you think would be a good one for us to address, send it our way. Hit us up at watersmarts@snwa.com or go to the contact page on the Southern Nevada Water Authority website at snwa.com. We'll be sure to get back with you with an answer. And hey, if your question is a good one, it might just make it on the next podcast. We'll see you next time here on Water Smarts.